Good morning, everyone. So today my talk is on the advantages of mobile mapping for highways condition analysis. So my name is James Tyndall, and as mentioned, I am the mobile mapping specialist for KOREC Group. We are the UK dealer for Trimble Geospatial, which is a supplier of all things survey and mapping. So if it measures it, if it maps it, we're involved. So today's talk really is, well, the objectives of what I want to get across today, and what I want you leaving with today is an understanding of what mobile mapping is. It's a bit of a buzzword, but ultimately, hopefully you come away today at least knowing what it is. And more importantly, how it can be used and adopted within local authorities, okay, especially for road condition and asset management. There are so many assets that, the likes of yourselves needs to be on top of, whether it's the condition of them, the location of them, but also in terms of the actual road surface detail as well. We all know that the potholes, the condition of our roads are deteriorating and becoming a huge issue. I think that's no big surprise. So how can we best manage those roads and have a more of a proactive, and a less of a reactive way of fixing them? So first of all, what is mobile mapping? So I've got a very nice sort of articulate sort of definition here from the Trimble website, and it basically says that vehicle-mounted mobile reality capture systems integrate georeferencing technologies, so GNSS, to position itself, along with precise high-speed laser scanning technologies, that is LiDAR. So that's what gives us that 3D digital twin of our environment. And this allows us to rapidly collect enormous amounts of accurate georeference and spatial data, which can be transformed into 3D models, maps, and GIS deliverables. So here's an example, probably won't play, but basically is a point cloud here that you can see is made up of literally billions and billions, if not trillions, of individual points. Okay, so the systems that we use on a daily basis range from capturing 1 million points per second to 3.6 million points per second, in conjunction with high-resolution images of the back down surface of the vehicle. So you get that high-res image of the road surface, as well as side cameras for your pavement analysis and your pavement inspection, as well as high-resolution 72 megapixel panoramic images as well. All on a moving vehicle, whether it be a car, a train, a boat, whatever it is that can take the weight. And that basically allows us to create a very high-resolution, high-density digital twin of our environment. Now, the uses of this go far beyond local authorities and survey, and it can be used in such a wide sort of number of industries. But there is such an important use case within this specific environment where we are today in local authorities. And what we've seen from the conversations from already today and yesterday is that the current methodology of utilizing or understanding the condition of your road, so where the potholes, the cracks, the rutting, all of these problems, the way they're combated today are often quite manual, using quite manual techniques, tablets, sort of bits of paper, people going out on site, boots on the ground to collect this spatial information. Not only is that going to add to the cost in terms of actually fuel, for example, to get out there, reducing the accuracy. It's a bit subjective as well on what people would determine an actual crack or an area of concern. So by having the ability to drive this area, whether that's through us, KOREC as a service, or yourselves, because you can do this yourself as well, it just allows for much better spatial information and allows for that data-driven decisions to be made. So from a top level then, what is a road condition sort of survey? I guess we all know sort of what I'm talking about here. It's just a way of monitoring the condition of the UK roads, and it's typically done through scanner vehicles. I'm sure you've seen these either on the roads or in your everyday lives. Now, these are fantastic tools and not anything that we're trying to compete with or remove. But the area that we're coming from is that these vehicles are so specialist. They are specifically made for this data collection, but they are almost specifically looking at the road surface in itself. The solutions that we have are more of a holistic data collection method. It's creating that not only that point cloud to allow us to run those crack detections, the rutting analysis, but creating those and capturing those images for allow us to do the asset management, to understand how many lampposts, to understand the street furniture and the condition of them, all within one capture. And actually, interestingly, I came across this article from, it dates back to 2021, but ultimately it's basically the Department of Transport, funded this paper to be made on how best to collect data. We're so used to the past, having this scanner survey vehicle is the only way of actually collecting our spatial information for our road conditions. Are there better ways of doing it? And out of their paper and their research, they had 3 options, and the one they decided to take forward and push for was option 3, which is to allow local authorities to choose any survey technology that aligns to a new industry standard. Now, the reason they've done this was several-fold. Ultimately allowed you guys to be in control of how you collect your data and for what purpose. So you might only be interested in your asset, your street furniture, or you might only be interested in your road detail, or it might be everything. So actually, to give you the control about what you want to use is very important, because that does differ from local authority to local authority and project to project. The adoption of a data standard would ensure that data remains sufficiently robust and comparable. And that was one of the problems, maybe the negatives of allowing these sort of technologies into this space, is that there are so many different mobile mapping systems out there. How do we make sure that the data that comes out of it is consistent? But the research that's been done, does actually back up the fact that all of these systems do and can conform to a consistent standard in accuracy. The systems that we supply, for example, have relative accuracies of 1 to 2 millimeters, which is hugely accurate, as well as high resolution imagery. So if they can all conform to that high accuracy of relative accuracy, then there's no reason to snub it. Also, removing the prescription of a single technology allows for, more competition and innovation in the field. If there was this understanding from the top level that all of these road condition surveys and asset management surveys have to be done with one technology, it completely stops innovation. And that actually, as you'll see in a minute, through the software that we use, it's a clear byproduct of that decision. We are now able to do things that actually we wouldn't have been able to do previously had the decision been that all road condition surveys have to be conducted through these single sources of technology. And what I find really important actually is this last bit here that ultimately says it allows us to help target resources where it's needed, reducing the cost of site surveys. So mobile mapping allows for a targeted approach. We've not got to survey an entire area and then fix the entire area. We can survey entire areas and understand the specific areas that need fixing, that are a high risk of, failing ultimately. So in today's world, the latest technology on offer, what we at KOREC Group and Trimble offer are these 2 systems. And at the risk of sounding too salesman-y, these are the very top of sort of what's available today. And they range from the yellow one in the background, the MX50, which is a highly accurate dual head LiDAR system with a panoramic camera that can be scaled up to incorporate more high resolution cameras, thermal, GPR, and all of these additional sensors. The one towards the front of the image is the MX90. And this is what has the back down camera, the side cameras, basically everything, and the very high resolution LiDAR rate of 3.6 million points per second. So by utilizing these technologies, depending on your use cases, can allow you to operate way more efficiently and perhaps not overspend. So for example, accessing that MX50 at the back is a lot cheaper than utilizing the MX90 at the front. But if it's just asset management you need to understand the location of your street furniture, the one at the back is absolutely more than adequate. But if you need to run crack detections and road analysis on your road surface, you would need to use the MX90. So we're no longer creating an area where we're pigeonholing you into using a single technology. You've got access, at your fingertips of using whatever technology it is, depending on the project. So although scanner survey vehicles are fantastic and they absolutely have a purpose, absolutely no disputing that. there are other survey technologies that can help you in your everyday, lives. So here's an example, just finally, appreciate I've not got a lot of time. This is a panoramic image of the MX9, going through a local authority. So you can see straight away we're getting real-world, up-to-date panoramic images of the location of interest. Maybe before you would be utilizing Google Earth, Google Street View to understand the assets in your area, which could be a decade out of date. That is fantastic in itself, and that's a useful product. But layering that up with LiDAR, 1 million points per second, 3.6 million points per second, allows us to see beyond that image. It allows us to utilize intensity-based returns from the LiDAR to understand things that are perhaps hidden to the naked eye. And this comes back to what I'm saying earlier about, the Department of Transport, for example, not pigeonholing us into using a single source of technology and thus, reducing innovation and slowing innovation. By allowing people such as yourselves and local authorities to use more and access more, different technologies, it allows us to actually advance our softwares and what's available at our fingertips. So we've been able to use LiDAR and automatically extract defects within the road surface to a very high degree of accuracy, sometimes well beyond 90% of accuracy. Now, a lot of this is stuff that perhaps wouldn't be visible to the naked eye. So if you're sending, operatives out in the field, they might be looking for the obvious cracks and the potholes within the road surface. But this 1 to 2 millimeter LiDAR is able to actually understand the rutting within the road surface, where they're seeing constant traffic, constant areas of hard braking paths for roundabouts. And we're able to not only highlight it, but also vectorize it, which allows it to be pushed as a shapefile or a DXF or whatever it is that you guys use at the moment, and use that within your current realm of equipment, whether it's tablets, GNSS systems on site, your existing GIS software such as maybe Esri, QGIS, field maps, whatever it might be. What it also does, it goes beyond just highlighting and vectorizing it, but it actually gives it a score. So what we can see here is an example of a carriageway. And once you've run that analysis, it then breaks it up into sample units that you're in control of. You decide how much a sample unit is in terms of length. And basically gives it a score and highlights basically gives it a color-coded score. So I can see, obviously I know what I'm looking at, that sample 5 and sample 6 have failed in their PCI score, so pavement condition inspection report. Red in sample 7 is failing, and green is absolutely fine. So if you scale this up to a much larger area, you'll be able to understand and target and put your budget, put your resources where it's needed most, as opposed to fixing that entire road and closing that entire road at cost just for the sake of unit 5 and 6. Another example is actually how we can overlay this onto Google Earth, and actually you can see on the left-hand side where we're getting quite a lot of potholes and bumps and depressions in the road. So it really brings to life the problems that you're facing. It also actually then gives it a name, identifies what a pothole is, a rutting, a crack, etc. is within its own database, and could also give it a depth. So if you've got potholes, it can understand, because of that 3D LiDAR element, you couldn't get this out of imagery, the LiDAR element allows us to give us a depth of that pothole, a width and a size. And using the parameters that you can input into the software, you can highlight potholes of specific sizes. So you're not going to concern yourselves with the little potholes, it's just the big ones that are going to perhaps cause serious damage to vehicles and thus maybe detrimental financial implications to yourselves as local authorities. So you are in control at every stage. It's not a one-button push, everything's done. It is, once you've set the parameters. And then, we all have a report. So it also goes into outputting a report as well as a CSV or PDF. So as you can see from this, I can see on my screen, we can see that it breaks down all those sample units. You can see that PCI rating in the color-coded format that makes it clear and concise about where the problems are in the road. But then also goes on to understand and tell you the distress types. So for example, unit 0 and 1 have no distress types. 100% on the PCI score, perfect road condition. Nothing needs to be done. However, you look at sample unit 4 and 5, it is poor or failed, and it has distress types such as bumps, depressions, potholes, and rutting. And then it allows us a fill or a cut volume, which then actually, if you take seriously, allows you to understand how much material is needed to fill said potholes. So finally, just a few more visuals of sort of what's possible. We take up here an area of road. We can see a lot of spatial information there, a lot of data. But if you're just concerned with the road condition, you highlight the road that you're interested in and you run the analysis. So we can see blue is everything that's less than 30 mil beyond the mean of the road surface. So it calculates the mean level of that road. So what it should be, really. Anything below 30 highlights in blue, anything in red is above 30 mil. So you can see where the depressions are clearly in a visual sense. And then you've got the vectorized information as well. This can all be pushed into AI sort of utilization, sort of workflows, but also augmented reality. We offer, I know it sounds a bit futuristic, we offer headsets and handheld devices that you can use on your phone that you've got already, go to site, and literally visualize everything you see there in the field overlaid with the real environment. So if you're doing site walks or you're trying to understand where that pothole is or where that rutting is that maybe not be visible to the naked eye, you've got the ability to take your phone, your handheld device, go to site and just check, spray up and take action. But obviously beyond that, we've got the other assets at our disposal as well. You've got our poles and signs on the side of the road as well. So if you're interested in asset inspection, asset condition, asset management, you've got that as well from the single source of information, the single source of truth. And all of this can be shared and collaborated internally via a portal. So we have our own portal, which is called Clearview 360, which is on display at stand number 14. All of your information, whether it be the raw imaging, the LiDAR, the vectorized information, any 3D information, PDFs, whatever it is that you've got at your disposal of your site, can be loaded up onto here, and you can see in Great Britain all the areas that we've got data. And that can be all worked on internally at the same time by multiple different departments, which makes sure that everyone is working off that same data set at the same time. So in conclusion, survey-grade mobile mapping systems are approved for use by the Department for Transport and actively encouraged. They encourage the use of it. Whatever works best to get the best result is the best decision. It allows for significantly large areas to be surveyed. It allows for data-driven decisions, which will ultimately improve outcomes. It has its proven repeatability. That 1 mil to 2 mil accurate relative accuracy of the LiDAR comes with a 1 to 2 mil precision. So every time you go out there and capture it, you can be damn well sure that that accuracy is the same every single time. Yearly captures can be agreed in your budgets every year. So we've already got budgets and local authorities, commissioning large-scale captures through 2025 and 2026. There's no hidden costs. We're not being reactive, we're being proactive. They've already got their assets from maybe in 2019. They're now ready to do it again going into 2024, 2025 to understand how their local authority has changed, to make sure they're understanding and aware of the conditions of their roads. And the ability to share and collaborate within your council businesses is something not to be understated. Utilising that same information across your business is so important to ensure efficiency of outcomes. So, yes, obviously I don't have a lot of time today, but I hope that I'm on time. But ultimately, I hope you've come away knowing that actually the technology available today is improving every year and is becoming much more popular in local authorities. The conversations we're already having today and yesterday are echoing this and shows that we're on the right track in pushing this technology to you, allowing you to access it. Now, they are accessible through purchase, but obviously they are quite chunky in price. But we do offer professional services, which we've been doing for many, many, many years with many local authorities. The like of Derby Council have invested in mobile mapping systems. There's some local authorities who invested in a service where they tell us the area to be surveyed and what they want out of it. And we deliver to them in a portal all of their information and all of their assets. So they've just got to sit back and watch the data flow in and then start then decide on their next steps. So I hope it was useful. I hope that it was worth coming along today to this presentation. Happy to take questions now. If not, we're on stand 14, which we can go in a lot more depth with some live data sets to show you what else is possible in more detail. So thank you very much.
Great.